morning friends. So today our topic is polymer. We will revise polymer through question and answer, and for that I took GSET questions. Okay. So first question is the number average molar mass for a monodisperse polymer is related to weight average molar mass by the relation. So it is related to dispersity. So actually this is polydispersity index, PDI, polydispersity index, and this polydispersity index is equal to weight average molar mass to the number average molar mass. Okay, so for monodisperse polymer means PDI should be equal to 1. PDI equal to 1 means ratio of the weight average to number average molar mass should be equal to 1. That implies weight average molar mass should be equal to number average molar mass for monodisperse polymer. Okay, so relation should be correct. Okay, now come to second question. Is for a polydisperse polymer, osmometry gives, osmometry, it is vapor phase osmometry as well as membrane osmometry. So osmometry is related to osmotic pressure, means this is related to colligative properties, even cryoscopy, right? So they are all depends on number, so it will give number average molar mass. Keep in mind, for Z average molar mass, ultra centrifugation technique is used. For weight average molar mass, we use light scattering method, and for X-ray scattering we get number average, weight average as well as Z average molar mass. And for viscosity average molar mass, we use HPLC. Two techniques are there. HPLC is also known as size exclusion chromatography, SEC, and GPC, gel permeation chromatography. These are used for viscosity average molar mass. So right answer for osmometry, it gives number average molar mass. So these are the questions from GSET 2019. Just note down. Third, fourth and fifth are from GSET 2018. First question is scientist who first used the term polymer. So it was none other than Visnagar. He was the first person who used the term polymer. Okay, so Visnagar is the right option. Then in a condensation polymerization of process, 99% conversion was achieved. Then the average degree of polymerization will be, see, it was by Carruthers equation. According to Carruthers equation, average degree of polymerization is equal to 1 upon 1 minus P. This P is fractional conversion. Okay, this P gives us the value of fractional monomer conversion. Okay, and it is equal to N naught minus N by N naught. N naught is number of molecules present initially as monomer, and N is number of molecules present after time t. So this is the fractional monomer conversion, and its value is given to us, that is 99%. That means 99 over 100 means 0.99. So in this way, average fractional conversion is 1 upon 1 minus 0.99, and is 1 upon 0.01, that is equal to 100. So 100 is the option. Okay, so for step growth polymerization, we can say condensation polymerization, we use Canother's equation to calculate average degree of polymerization, and it is related to fractional monomer conversion. Okay, now next, which statement is true for synthetic polymers? So keep in mind, for synthetic polymers, it is always polydispersed. Polymers are always polydispersed, means PDI should be always, means polydispersity index should be greater than 1. For natural polymer, they may be monodispersed. Okay, but synthetic polymers, there is always PDI greater than 1. That means they are polydispersed polymers. Means weight average to number average value should be greater than 1. Ratio should be greater than 1. That means weight average molar mass is always greater than number average molar mass. So that means right option is C. Got it? Next, sixth question is from GSET 2017, 7th and 8th from GSET 2016. Very easy questions. First is the catalyst used in Ziggler method for polymerization of ethylene. So Ziggler meta catalyst, and that is titanium tetrachloride and triethyl aluminum. That is the right option. Everyone knows. If you don't know, then note this. This is Ziggler meta catalyst. It is used to polymerize ethylene. Okay. Next, which of the following methods gives number average molecular weight? Just now we have done that osmometry method, cryoscopy method, osmometry, vapor phase osmometry, membrane osmometry, cryoscopy, all are used for the measurement of number average molecular weight. So option D is correct. Easy. Now last one, propagation step occurs in chain reaction, obviously chain initiation, chain propagation, chain termination. Chain reaction, parallel reaction not. First, parallel reaction is if we have A, from A we get B and C. That is called parallel reaction. Here there is no propagation step. But polymer reaction is the general term, and chain reaction is one of the thing that undergoes polymerization. So A and C both are under the heading that propagation step occurs in chain reaction, and chain reaction leads to polymer formation, right? So polymer reaction and chain reaction, so both A and C, right? Okay, so these are the questions up to 2016. Just note down, then we will go to the next question. 9th and 10th question, they are from GSET 2014. Question 9 is, at any time during the course of chain polymerization, the reaction mixture contains, so you know, when chain reaction takes place, chains are adding up, so high molecular mass polymer is formed, and polymer monomers are going to be added one by one. So that means that during the course of time, at any time, there is monomer as well as high molecular mass polymer chains. Next question is, nylon can be prepared by any one of the following rearrangements. You know, nylon 6, it is obtained from caprolactam, and caprolactam is obtained by which method? So the Cartesian arrangement gives isocyanates, and then amine. Lawson arrangement again isocyanates. Smitted arrangement, different products but not caprolactam. But Beckmann rearrangement gives caprolactam by this reaction. See, we have first cyclohexanone. Cyclohexanone will react with hydroxyl amine. We get cyclohexane oxime. Okay, and then cyclohexane oxime in the presence of H2SO4 undergo rearrangement, and we get the product caprolactam. Okay, and when heated at 533 Kelvin. Up to this is Bakeman rearrangement, and then in inert atmosphere we get this breaks from here. So 1, 2, 3, 4, 5, and then NH. So this is the nylon 6 as the product formed. Okay, so Bakeman rearrangement is the right option for 10th question. Okay, so note down, and then we will go to the next question. Next 11, 12 and 13 questions are from GSET 2013, and last question 14th is from GSET 2011. Question is, termination under controlled conditions often does not occur in anionic polymerization, cationic, free radical and solution. So keep in mind, in cationic polymerization, free radical polymerization and solution polymerization, there are formal termination steps, or we add terminating agent, okay, terminator. But in anionic polymerization, there is no such formal termination step. There is only initiation step and propagation step. Means in anionic polymerization, leaving polymerization takes place. Okay, that's why A option is correct. Right? Now, what is the repeating unit in the structure of 12 crown 4? It is crown ether. So keep in mind, crown ether is like this. See, numbering can be done from any side: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So total 12. It is crown shape and 4 oxygens. Okay, so repeating unit is O. This is CH2, CH2. So this is the repeating unit. That means C option is correct. It is written crown ether. Name itself tells us about the presence of oxygen. Okay. Then carbon nanotubes are members of which structural family? Very easy question. Glycerol, polyolefins, fullerene and amines. Obviously there is only one option which is close to this, that is fullerenes. So carbon nanotubes are members of this fullerene structural family. Okay. Last one. Which of the following is not an addition polymer? So there are two types of polymer: addition and condensation. For addition polymerization, what is required? At least one pi bond, double or triple bond. But in case of condensation polymerization, requirement is of at least 2 functional groups. Okay, so let us start with PET. PET is actually polyethylene glycol and terephthalate. Right? So it is obtained from polyethylene along with terephthalic acid. So terephthalic acid is this. So see, there are 2 functional groups, requirement of condensation polymerization. Okay, so we get CH2, CH2, O, C double bond O, sorry, yes, this C double bond O. Okay, so in this way we get the desired product, or sometime it is like this. Okay, so PET is a condensation polymer. Okay, PVC, you know, C double bond. sorry, CH2, this is vinyl group, Cl. So this is the polyvinyl chloride, and it is addition polymer. Then come to high density polythene, means it is obtained from ethene. Again addition polymer. Polytetrafluoroethylene, Teflon, it is also addition polymerization. So that means only one first is not an addition polymer. Okay, so these are questions from previous year GSET papers. Now I will, as a bonus, I will explain one topic to you, so be with me. So let's have relations for number average, weight average, Z average and viscosity average molecular weights. So for number average, what we do? We take summation of Ni, Mi divided by summation of Ni. Here I is number of chain lengths, Ni and Mi, right? So that is molecular mass of each length and number of chains with molecular mass Mi, Ni, that is the thing. Then come to weight average. It is summation I, Ni, Mi square divided by summation of Ni, Mi, right? And Z average, that is equal to summation I, Ni, Mi cube over summation Ni, Mi square, and so on. And Z plus 1, so it is 4 and 3 likewise. Okay, and next one is viscosity average. So viscosity average, for that we use Markovic equation, and that is equal to viscosity equal to K and then viscosity average molecular mass raised to power alpha. Okay, this is, and Kn and alpha are, K eta and alpha, these are Markovic parameters. Okay, from this we can calculate viscosity average molar mass, and that is equal to summation Ni, Mi raised to power 1 minus alpha divided by summation of Ni, Mi raised to power 1 upon alpha. Okay, sorry, it is 1 plus alpha. Okay, so if alpha is equal to 1, then this term become weight average. Okay, if alpha equal to 1, then it is weight average, right? Otherwise alpha, maximum value of alpha is 1. Okay, otherwise it is less than 1. Alpha, maximum value of alpha is 1, then it becomes weight average. Otherwise it is always less than weight average. So what is the relation? Number average, weight average, Z average. This is the relation between these three. So where we kept this viscosity average? So keep in mind, viscosity average is greater than number average and less than weight average. Z average, Z plus 1 average, they are. Then what is Z plus 1? It can be written as, let us write here, MZ plus 1. So that is summation Ni Mi 4 over summation Ni Mi 3. So as we go on writing this Mi below and above, value goes on, average molar mass goes on increasing. Okay, so this is the relation. Okay, and for monodisperse it may be equal. Okay, but for condensation polymers this is the exact relation, means polydisperse polymers, this is the exact relation. Number average molar mass is least, then viscosity average, then weight average, then Z average, then Z plus 1 average, Z plus 2 average, and so on. Okay, so that's all about polymer from the previous year GSET questions. Thank you very much for watching this video. Do like, subscribe and share my channel. God bless you all. Happy learning.